Okay, continuing on with our game, it's time to actually build our player. So to build our player, we're going to create a class called player. And that class is going to enable us to abstract away the details of like working with all of the nuances of what it means for a player to move, and just think about these as like broad ideas like updating and drawing the player icon wherever it should be. So the first thing that we need to do is we need to say whenever we construct a player, let's define a constructor method. The player is going to be placed at an x and a y coordinate, which will be the arguments or parameters of this function. So that player, we're going to store these x and y coordinates as belonging to that player. So we're going to use the this keyword. So the player's x coordinate is equal to whatever x value we give it. The player's y coordinate is equal to whatever y coordinate we give it. In addition to this, the player image is going to be stored inside of this player abstraction. So let's say this dot image is equal to player image. And that's going to say that the image for our player is this thing right here that we created earlier. So that should be good. Now, this player is going to have a couple of other methods. We're going to need to be able to draw our player on the screen. So when we draw the player, it's going to be a function. And what we want to do is we want to draw the player wherever it currently is. So to do that, very similar to when we drew the background, we're going to do ctx.drawImage. But what's going to change is, instead of drawing the background image, we're going to draw whatever image we stored as the player image using this dot image, at whatever its x coordinate is using this dot x, and whatever its y coordinate is using this dot y. Okay, so now that we've defined what it means to have a player in our game, we're going to have to draw the player inside of our load function thing here. So we go into our load function, and actually, after drawing the background, let's create a new player. So let player equal new player. And we have to give it an x and a y coordinate because that's what we specified in the constructor. So let's just randomly pick 300 and 200. Next up, we need to actually draw our player at that location. So we're going to say take the player that we just created and run the draw function or the draw method for that player. So saving it and refreshing it, we now have the player there. So the way a game works is pretty simple actually. There's something called the game loop, which is a function that loops over and over again. And what this function does is it updates the character and then it redraws the character in its new position. So what might happen is if the character moves, it will know in advance it's moving here. So that will be the update part of the game loop. And then it will run a function called the draw function. It will actually draw it where it is. So let's create this function. So function game loop. And the way that the game loop calls itself over and over again is the very last line of the game loop is going to recall the game loop. So let's just outline what it does here. So update all sprites. And in general, these little characters here are called sprites. So when it's just the player, it will be just the player, but then later it will be food and enemies. Draw all the sprites. And then finally, recall the game loop so that it loops. And the function that JavaScript uses to do this is request animation frame. And then we put the game loop function itself inside of this. Okay, so we're ready to start defining what these things mean to do. Now, similar to what we had before, well, when we draw all the sprites, it looks like that's just going to be player.draw. So let's cut this out from here, and let's put this down here. So here it's player.draw. For updating the sprites, it's helpful for us to rebuild on our abstraction of a player what it means to update. So this player is going to have an update method. And that update method is going to be, okay, well, as it moves, this is going to be a continuous action game, so it's always going to be moving. In fact, we're going to give our player a speed of 2. And so let's start the player off moving to the right. So what that's going to do is every frame of the animation, it's going to take whatever the x coordinate currently is, and it's going to add the speed to it. And we're going to make this the new x coordinate of the sprite. So every frame, the old x-coordinate added by 2, added by the speed, is going to be the new x-coordinate, which is going to create the illusion of it moving to the right. So let's give this a save and a refresh. Okay, nothing happens. Let's take a look at the JavaScript console. No errors, okay. Well, I forgot a couple of things here. When we update all the sprites, well, the first thing is the abstraction is really powerful here. We don't have to think about what it means to update this player. We just say player.runYourUpdate function. And we'll have to dive back into this abstraction to improve it later. But now we're going to update the player, draw the player, and then request the animation frame. So it's going to keep doing this loop over and over again. But in order to start this loop going, we actually need to create the game loop down here and run the function. So let's give it a save and a refresh. Whoa! Okay, so a little bit not what we expected, but what's happening here is as it draws on the canvas, it doesn't erase the old drawings automatically. So before drawing the player each time, we need to draw the background. So let's copy that draw background line, and when we redraw the background, what it's going to do is it's going to draw the background image on top of whatever the old image was. Then it's going to draw the new player on top of that background. And I think this should look a lot better. Great, so we've got our player moving. All right, so our update function needs to be a little bit more complicated. One thing is that our player is actually crawling off the screen. So we have a couple of choices. We can make him bounce, or we can make him like Pac-Man style warp to the other side. And I think Pac-Man style warping to the other side is a little cooler. So let's say if this.x is greater than the width, then what we want to do is we want to set the x-coordinate. So if it's greater than the width, what that will mean is our little guy has gone off the screen over here, and we want it to Pac-Man over here, so we'll make his width, or sorry, his x value equal to the x value over here, which would be 0. Okay, but this isn't the only possibility. We could say, what if he crawled up the screen this way? Then his x value would be less than 0. And what we want to do then is we want to set his x value, if he crawls off the screen this way, we want to set his x value to the width so he appears on this side. So this is else if, sorry about that. All right, here, if he crawls off the screen on the bottom, that would mean that his y value is greater than the height. And we'll set his y value to 0. And if he crawls up the screen this way, it would mean that his y value was less than 0. And we'll set his y value equal to the height so that he appears down here at the full height of the screen. So let's go to save and a refresh, and let's see if that works. Whoa, cool. Okay, so he does warp through the screen, which is pretty nice. Okay, let's see what else we can do. Now he can only move one direction. So what that should make us think about is his direction is going to be changing over the course of the game. So let's give him a direction. This dot direction is equal to right, because he starts out moving right. So instead of always doing this, we next want to run through a series of checks. Well, actually, before we run through this check set, we want to run through a series of checks here, which is if this dot direction is equal to right, equal to right, then we want to add to the x-coordinate. Okay, similarly, if the direction is left, then we want him to move backwards, so we want to subtract his speed from the x-coordinate. So if it's left. Okay, if he's moving up, so else if this dot direction is up, then we want to subtract from the y-coordinate so that it moves up. So this dot y is going to be changing now, will equal this dot y minus this dot speed. And finally, else if this dot direction is equal to down, then we want to take his y-coordinate and we want to add the speed to it so that he moves further down. So it looks like we've got the directionality set here, so let's give it a save and a refresh. So if his direction is right, he works. Let's try it with up, because we haven't seen that. So we change this dot direction to up, and now he's moving up. We check this dot direction is down, so now he's moving down. And we should check all of these, right? to help us debug our code. So now if he's moving left, and let's see if that works. Cool. So then the last part about updating for the player is we want the player to be responsive to the keyboard so that the direction is changing. So before checking the direction, so let's add some comments. Update based on direction. Here is if player crawls off the screen, make them reappear on the other side. It looks like the last... Okay, so I had a bit of an error and I got to reshoot this part of it. So for this part of it, we've got the update all set up, and now we need to add the event listener part. So we don't want to keep adding an event listener every time that we update the frame. So we're going to do this actually outside of the player abstraction. So right here when we create the player, let's add an event listener to the window. So let's do window.add-event-listener. And the event we're going to listen for is a key down event. And whenever we have a key that's pressed, it's going to create an event variable. We're going to pass that event variable into the function. And we're just going to start off by doing a console.log on the event. So let's refresh our game. And let's open up the JavaScript console. So whenever we press an arrow key, it's triggering an event. And that event is actually a complex object that has a lot of keys and a lot of values. Now the one that's important here is actually the key that's named key, which tells you which key is pressed. So depending on which key is pressed, we want to do different things. So what we're going to do is we're going to say first console.log, instead of just the whole event, the event with the key. So saving it and refreshing it. Oops. Sorry, I have to click there. And now we can see that whenever we press a key, it tells us which key is pressed. Sweet. Okay, so what we're going to do with that is not just console log it, we're going to say if the event key is arrow right, then we're going to set the direction of the player to be right. So player.direction is equal to right. Okay, so we're going to copy and paste this a bunch of times, and we're going to do it for left, uppercase left here, lowercase left here. We're going to do it for down here, lowercase down here, and we're going to do it for up here and up here. So we're creating the player, we're adding an event listener to the window that says depending on what key is pressed, change the direction of that player to each of those directions. And then once we run the game loop, depending on what direction the player is facing, it will change how the player's position is based on the direction he's moving. So let's give it a save and a refresh. And now our player is completely functional. So just leaving the code up on the screen. This is a really big moment for us. We've got a player that works, and that's pretty exciting. So we'll start to create some obstacles for our player and some, I guess, rewards for our player in the next videos.